This devlog, we're going to improve the water. Remember this big blue square that I put into the game as a placeholder back in the day? Well, it was there for about 2 years. Finally, I decided it was time to get this thing sorted because I do want to make a game that actually looks good. This is a game about exploration and discovery in a high fantasy world. You find things, kill monsters, level up, and gradually the story of the game unfolds before you. It's all about finding things, and maybe you might even find yourself. I make a devlog each week and we're rapidly approaching devlog 69, so make sure you've hit that subscribe button because it's going to be a big one. So what actually is the point of improving the water when I could just be slightly improving the vertex count like last week? Say you're swimming but you're not very far from the land. It would be nice to highlight that area as being quite shallow water. Aside from just being a cosmetic thing, maybe this could also be a gameplay thing, as the player might swim slightly slower when they're in deeper water. And as far as the cosmetics go, I'd also quite like to get the odd scrolling texture going, just like basically every other game in the world. And also look into doing some vertex shader animations to really sell the effect. The first step was to go through my map data and generate a single texture which I could apply to a plane to show the deeper and shallow parts of the map. This in itself wasn't actually complicated. The thing that complicated it was that I tried to be smart and reduce the amount of memory I needed for the texture by changing the pixel type. So rather than using the standard red, green and blue channels, as well as the alpha channel for a single pixel, which came to 16 bytes per pixel, which is gross, I instead decided the best thing to do would be to use a single channel, which in this case was red, and also limit that to be one single byte, so that's 0 to 255 values. So the plan was to do essentially what the old school video games used to do, of have a color palette and then your actual sprite definition here, meaning that you didn't really need anywhere near as much memory. So the plan itself was, even though the texture was absolutely blood red, I could fix it up in the shader and make it totally family friendly. So this turned out to be my first existential crisis, apart from all the other ones that didn't make it into this video. I'm using my own game engine for this project, which in turn uses the open source rendering engine Ogre 3D. Ogre actually has quite a well thought out solution to the Uber shader problem, which is this preprocessor system that can generate shaders for you on the fly. So what that then allows me to do is just write a few custom pieces which can then be inserted into the final shader. The problem that I ended up having to deal with was that I was only able to insert pieces into the shader. I wasn't necessarily able to go back and change what had already been generated. So that meant that I just really lacked flexibility. I was kind of swimming against the tide, get it? And I started noticing weird graphical glitches like this cloud shadow just still being computed against the plain red texture. And I decided, as time was against me, to scrap the single channel texture idea and just generate a normal, inefficient one. I'll have to come back to this problem later though, because really what I need to do is modify my engine in a way that it can start to unlock some of the more complex modifications you can make to Ogre's shader system, because there are quite a few. So now with my texture having put on some extra bytes, I was able to draw it to the scene even with shadows now correct. The next step was to animate some nice overlay patterns on top of it. As this is going to be a stylized game, obviously I went for the look of the best stylized game ever made, Zelda Wind Waker. I drew some nice simple tiling textures in Photoshop and, using Ogre's material system, stuck them on top of the ocean plane. The next problem though was that these wave textures were being applied everywhere, even in the shallows and in the lakes. Luckily for me, it is actually possible to use a detail map mask to limit where some of these things are actually applied. You just assign one of the RGBA channels in the input texture to one of the detail layers, and depending on how bright that pixel channel actually is, depends on how much the final thing gets blended. So I generated one of these textures exactly as I did with the other one on the CPU, and just slapped it into place. So I thought the water was looking much nicer now, and because you can actually modify how bright detail comes through with the maps, I was able to put a tiny amount of the wave texture into the shallow areas. So the last major hurdle for this week was to actually get the water to animate up and down. To enable this, I modified my terrain voxelizer to draw the lower sections of the terrain to be a bit longer, so I had more space to animate the up and down. This did lead to some wraparound issues, but I was able to work through that by offsetting some stuff in the shaders. And then, okay, this is a very sad recording because I lost a lot of footage yesterday. And that was also the climax of the week where I got all this ridiculous stuff to work. So I'm not very happy about that. So I'm basically just going to go over and recount what I did step by step for you guys, because I love you. So probably the first thing I did was go and create another plane. I've essentially just taken a plane and divided it up. So I got it positioned into the world like this. Now you can see it's very beautiful. It's just totally flat for the moment. The player looks like he's having a great time there. So in the next bit of all that footage that was destroyed, I managed to get this to work, which I was actually really excited about, and basically jumped on my chair and almost killed myself. But what you're essentially seeing here is me just applying a sine wave over the whole thing. The code exactly is just this, which just applies a sine wave based on where you are and multiplies it by 10 to make it nice and obvious. Yeah, it looks pretty trippy, doesn't it? Now, the next thing I did, which did actually take a bit of brain power to figure out, but I had to find a way to pass a float variable into the shader system. Now remember, I don't actually control the shader system. This is all handled by Ogre. Previously, in the other places where I was animating things in the shader, I was actually using the material to determine what time it was. The way this ended up working was I ended up just using the API, and you can define this HLMS listener, which gets called at various places, and you can see all this hacky code that I stuck in. So you're saying how many bytes do you actually want to pass to the shader. So I want to pass a single float, so it's just the size of one float, and then you just write that value. So mTime value is just a static variable, which I defined there, and then I update in the game core namespace. So I just add some random number to it. So this is how I'm getting my time value in, and it's really good I know how to do that, because I actually didn't know how to do that before. I've just never run into a circumstance where I've needed to do this. So once we have that value, then the shader can actually use it, and we get something like this. Look at that thing. That's majestic. And you really can do any sort of animation while using it. But this sort of thing is probably the quintessential example of the sort of things that the GPU can do. But yeah, we're getting there. If you actually start to put the multiplication back into say no territory, like 0.25 rather than 10 or whatever it was before, then you can see what you end up with is essentially just this nice kind of ripple effect. It does add a lot, I think it does. And my modifications to the side of the terrain was also a really good idea, because you can see it just kind of goes up just close enough. Now, the problem with this is it is still quite linear, because you can kind of see what it's doing, and you've only really got the wave going in one direction. So here we have a beautiful cos wave, which is the opposite of my sine wave. And if I add that to that there, so that immediately there's a bit more complexity going on for the actual animation. So one thing that's totally broken is the actual positioning of the texture. And I don't actually know why that is. And the thing is that when I get further out, I can also start playing with having bigger waves. So if you really want to go this far out, then yeah, I could animate the waves to a higher velocity than I can over here, for instance. So that's totally possible as well. But again, I would like to stress, I'm going to be coming back to this. This isn't the final thing at all. You can kind of see the water goes up to the point where the player wouldn't be able to breathe. But we're not going to talk about that. That's unimportant. Apparently when I teleport the player using my debugger tools, it doesn't actually check to see if they've switched to being in the water now, so it doesn't update anything. And on that note, I think I've probably run out of time for this week, so I'll see you next time. As you've made it all the way to the end, and therefore I assume are a true believer, please could you like the video and also, ideally, comment something down below, because I do think the comments are something that does kind of push the videos in the algorithm, and I would like to push it more in the algorithm, because the more eyeballs we can get on this project, the better it will do, theoretically. And the more likely I'll be able to switch from eating white bread to being able to eat wholemeal bread. That's my dream. And if the sight of all of those vertices at the end traumatized you, then why not watch this video, where I reduce all of the number of vertices in my meshes by about 3 times.